Science College, Congress Nagar, Nagpur. Today we have with us as a guest speaker Honorable Professor K Ahluwalia sir, who is the President of IAPT and retired professor from Himachal Pradesh University. I welcome you, sir. We have with us an eminent personality who was the guest on that 27th of Jan, Professor Srirup Rai Chaudhary, sir. Again, welcome you, sir. We have with us Honorable Guest Speaker, Professor Rajendra Modgil, sir, also. Again, I welcome you, sir. We have with us Honorable Professor R.M. Shevale, sir, who is the President of RC-08, along with President of Sub-RC-08E. Honorable Professor Shyamkant Anwane, who is the Head of the Department of Physics. Welcome you, sir. I heartily welcome all the participants, teachers, faculties, researchers, and dear students. I welcome you all again. The talk originally was scheduled on 27 Jan 2024, and it has been rescheduled today on 29th of Jan. This event serves as an extension of one-day seminar on the life of work of S.N. Bose. I'm very much happy and delighted to announce that Professor K Ahluwalia sir, a distinguished researcher in condensed matter physics and a professor at Himachal Pradesh University, who also holds the position of National President of IAPT, has graciously agreed to deliver his talk, which is titled by respected Master Albert Einstein, a life from physics. So without taking much time, I would like to request Honorable Professor R.M. Shevale sir to kindly introduce the today's guest speaker. Please, sir.
Thank you, Zado sir. Before introducing Professor Ahluwalia sir, let me take this opportunity and tell those participants who are not the life members of IAPT, please become a life member of IAPT. If you are working in your college, junior college, or maybe in school, then please start NSE Center for the various Olympiad exams from next year. If any help is required, you can contact to me. Thank you very much. Now, let me introduce today's speaker, Professor K Ahluwalia sir, who is retired as a professor in 2015 from Himachal Pradesh University in India. Since 1980, he taught at St. Bede's College up to 1987. And after 1987, till his retirement, he was in Department of Physics in Himachal Pradesh University in India. He is now presently working as an adjunct faculty at UGC IUAC, that is Inter-University Accelerator Center, New Delhi, and Indian Institute of Information Technology, that is IIIT Vadodara, since July 2015. He held positions like coordinator UGC, SAP, member in committees like State Higher Education Council, Private University Education Regularity Commission, Public Service Commission, Library Advisory Committee, UGC Nodal Center for Computer Applications in Physics, Mathematics, and Commerce, Dean of the Faculty of Physical Sciences, Dean Planning and Teachers Matters, Director Inter IQAC, that is Internal Quality Assurance Cell, Director University Institute of Information Technology, BOS Chairperson and member at Himachal Pradesh University. His research areas are condensed matter physics, in which we can mention his specializations in dilute magnetic alloys, chemisorption, liquid mills and alloys, low dimensional electron gas, quantum dots, computational material science, etc. Another area of physics of Professor Ahluwalia sir is physics education research. During his tenure of his service, he guided 18 PhD students and 34 MPhil dissertations as well. He wrote 3 books which are published on computational physics and related areas, edited 2 publications. He created research facilities like Nodal Center for Computer Applications, high performance computing facility of 128 crores for electronic structure calculations using DFT, upgraded research and training facilities under FIST and UGC, SAP, etc. His research publications are in more than 120 in high impact factor, peer-reviewed journals, and more than 3,090 research citations. He awarded Commonwealth Academic Fellowship at University of Edinburgh, UK. Also, he has been awarded as a Best Teacher, Academic Administrator, and Environment Leadership Award by Himachal Pradesh University. Sir has visited abroad countries like UK, France, Switzerland, Turkey, and Thailand. He took initiatives on the campus during his tenure of his service for University Institute of Information Technology, Wide Optical Fiber Network, High Performance Computing Lab, Database Design for Computerization of Himachal Pradesh University Examination Section. As a director, IQAC, he implemented student charter, designed and implemented teachers evaluation pro forma. Choice-based credit system under RUSA is also being implemented in HP. SWAT on the campus, RUSA coordinator, achieved ranking for Himachal Pradesh University among top 25 universities of the country, and it was resulted in grade A by NAC, as it was earlier grade B for this university. Ravi Bhavani, please mute yourself. As a dean of the faculty, he developed 12th five-year proposal for funding by UGC, also solar power projects of 50 kilowatt and community radio DPR. Let me mute my then there will be a problem. Okay. As a dean of the faculty, sir has developed 12th five-year proposal for funding by the UGC, also solar power projects of 50 kilowatt and community radio on the campus, DPR of 3.69 crores for computerization of the university. He has initiated the digitization of university library, etc. Sir has the different types of work like science popularization, radio feature writing, development of spoken tutorials, e-resources development, sketching and drawing are the interests of Ahluwalia sir. The last but not the least, sir is presently the president of IAPT at national level. He is a member of IPA. He is also a member of Indian Science Congress, associate president of Himachal Pradesh Physical Society, General Secretary of VIDRBHA Himachal Pradesh. With this introduction, now I request Honorable Ahluwalia sir to deliver his talk. Thank you.
Thank you, Professor Shivale. Thanks for your kind words.
Thank you, sir.
May I please be allowed to share the screen? Please allow me to share the screen.
I think you can try it, sir. You'll be able to share.
Am I the host? No, host disabled participant screen sharing. Okay, by the time this screen sharing happens, let me first of all thank you for such a nice seminar which has been organized by RC-08 in collaboration with sub RC-08E. And I think this is the initiation of another program of the IAPT, in which maybe every month IAPT can host such a seminar dedicated to, say, one of the physicists of the country. How we picked up the present seminar scientist was looking at who has been born in the month of January. And on 1st of January, you find that it is the birthday of Satyendra Nath Bose. Once it was there, we sat down with Professor Anwane, Professor Shivale, And we thought that let us try to do something dedicated to Satyendra Nath Bose. Similarly, IAPT wishes to organize these seminars throughout the year. Every month, one seminar dedicated to one Indian physicist, oblique scientist. I mean, it is not that we will have only this dedicated to a kind of a single physicist only, because physicists are in very many areas. To give you one example, we will find that physicists have in fact initiated very many fields, and then they really excelled in those fields. Professor Shivale, still I am not able to share.
Anwane sir, please see what is happening.
You make me the co-host, sir.
Rekha madam is coming to make you co-host.
Okay. All right. Let me just continue with what I'm saying. So as I was telling that we are going to really organize these seminars. This is one thing. Second thing, which was initiated in the first part of this seminar, was sending a kind of a submission to IUPAP, and we will work on that. The third thing, which also actually came as part of the chat and the discussion, was participating in identification of a heritage physics site in India and getting it on the website of American Physical Society. So I am very happy to tell you that Professor Deshmukh has already made a submission for Indian Association for Cultivation of Science. So that's a good beginning. But then we later discussed it among each one of us, and we found that there is another possibility which we can explore in IAPT itself. And that possibility is that we should have on our own website a web page dedicated to the heritage physics sites of India, for which we can follow a procedure of nominations to invite nominations from the members of IAPT, that which heritage site can be declared as the physics heritage site. And what IAPT can do is, IAPT can offer to put a what you call pattika there, a plaque there, telling that IAPT has identified this site as a heritage physics site of India, and also provide a reasonably good information on our own website. So this will in fact initiate another element of bringing among our stakeholders knowledge about the various websites. So I think this is what I briefly wanted to say. I think I will be able to now. I'm sharing the screen. Can you see the screen, sir, now?
Yes.
Yes, sir. Yes.
All right.
Yes,
It
sir.
is not getting full screen mode. So you
I'll do that. Don't worry. I'll just go do that.
your slideshow.
Yes. I have to go there. It's hidden somewhere. Yes.
Yes.
So I'm
Yes.
there.
Yes. We got it.
Yes. So I think we can begin now the main part of today's lecture. In fact, to talk about Satyendra Nath Bose and not to talk about Albert Einstein is something which will be, not paying the kind of tribute which we can pay to Albert Einstein, the way he identified the work of Satyendra Nath Bose of great importance to physics. there is one very interesting thing which is there in this is this, that the work of Satyendra Nath Bose was basically in quantum mechanics. Rather, I would put it in quantum statistical mechanics. And Albert Einstein was very much into it when you look at what he has done in his career. In fact, he was very knowledgeable about the foundations of thermodynamics. That's another very interesting aspect of the life of Albert Einstein, which really made him focus on what Satyendra Nath Bose had done. This is very important to note and appreciate why we are actually talking about Albert Einstein along with Satyendra Nath Bose. I think anybody who is talking about physics is definitely knowing about Albert Einstein. But Albert Einstein's personality goes beyond physics also. I think any high school student, if you show him this formula E is equal to mc squared, will immediately identify that this formula was given by whom. If in a quiz, if you post this picture, I think 100% audience can identify that this is the picture of Albert Einstein. So he is a kind of a, what you call a poster boy of science for the last more than 100 years. And that's the kind of personality which he possessed. Now, how he really became that is what I'll try to touch upon in this particular presentation. The idea is very simple. We will try to trace what he did when he was born. And this is a small, screen which I have taken from the American Journal of Physics, where we find that he was born in 1879, 10 years after Mahatma Gandhi was born. And he was born in a town whose motto was, and the name of the town was Ulm. I hope I am pronouncing it correctly. The people of Ulm are mathematicians. And you will see later that when he has to present himself for a small job somewhere, he presented himself as a mathematical physicist. That's a very interesting story behind the place where he was born and the way he actually progressed further in his career and in his life. In 1895, at the age of 16, he wrote his first scientific essay. And on the title of that was On the Investigation of the State of the Ether in a Magnetic Field. So now you can very easily realize that the ether as a medium for the propagation of electromagnetic waves was very much in the air at that point of time, and people were really looking at this. And he also started looking at this aspect. So you can see the seeds of his growth in the area in which he later really became a kind of a, I would say, to call him an expert is actually not right, to become a towering figure. Then in 1897, he met his engineer friend, Michel Basso. And for him, this friend was like a sounding board. You will realize that Einstein actually was doing very many things in an isolated manner. He didn't really find that there were so many peers around him with which he was in a position to discuss the things. But he had a good friend with whom he used to share what he was actually doing. In 1900, he graduated from Zurich Polytechnic. And there also, he, in his autobiographical notes, tells that thanks to his friends who were very meticulous in taking notes from the teachers who were teaching them, that he was able to pass the examinations and come out as a graduate of Zurich Polytechnic. In 1901, he becomes a Swiss citizen. And in 1902, his daughter Lizerie was born out of a wedlock to him and Mileva Marik. She was also a physicist. And this very interesting aspect of this is this, that not very many people know that what happened to his daughter. She may have died or been given up for adoption. And it was during 1902 that he starts work at the patent office in Bern. Now here you may also see that the daughter was born first and he married Mileva later in 1903. There's a very interesting timeline which is there. So when we look at his early childhood, let us try to see that what were his few early influences. He was very much, fascinated by a compass. And holding a compass in his hand and finding that it always points in a particular direction made him feel that there must be something very deeply behind things. That's why they behave like this. There was no immediate reason to find that why this needle is pointing in a particular direction, but he was convinced that there is something at the back of it which we may not be knowing. And another very interesting thing which he found was that what man sees before him by touch causes no reaction of this kind. So there was something, what you call action at a distance in the spirit of Newton, or what you may describe as the concept of that field which is there but which we cannot really perceive with our five senses. Also, he was very much, fascinated by a book on Euclidean geometry. And in his autobiographical notes, he writes, "It is marvelous that man is capable of reaching such a degree of certainty and purity in pure thinking." And in fact, he later tried to tell the meaning of thinking also. And I'll come to that later itself. Also, he had an uncle whom he has described as Uncle Jack. And he writes that Uncle Jack says algebra is a very interesting study. So here comes the fascination with algebra. That animal which we want to catch for a moment, we call it X, and keep on following it until we catch it. I think this is the kind of spirit with which Albert Einstein worked throughout his life. He will pick up some theme, concentrate on that, try to, arrive at some kind of a concept, and some pattern will start emerging from his thought process itself. And that is how he actually worked. So these were the three very interesting influences in his early life. In his student life, at 15 in a Munich school, he was in a class whose teacher told him one day that your mere presence spoils the respect of this class for me. I think that was because he would ask certain questions which his teacher never wanted him to ask while the class is going on. And at 16 and a half, he sat for entrance examination for engineering, but failed. I think this also needs to be underlined, that he was also trying to struggle and find a place for him, maybe later equip himself with some kind of a degree to get some employment. Next year, again, he sat, succeeded, and fortunately opted for physics and not for engineering. And that was good for science and for physics as well. In 1901, he wrote his first paper, which was published in Allgemeine Physik. That was his first paper which he published. I'm not coming to that paper as such, but I'm telling you only that that was when he wrote that paper. After its publication, Einstein wrote a letter to Professor Oswald. He is a very well-known name in chemistry. Any chemistry student, high school student knows the name of Oswald. And he wrote it in a very humble fashion. And he said, since I was inspired by your book on general chemistry, I am taking the liberty of sending you a copy of my paper. I venture also to ask you whether perhaps you might have use for mathematical physicist. This was what I was indicating earlier. So right in the beginning, he posed himself before the possible employer that he is a mathematical physicist. I am taking the liberty making such a request only because I am without means. And he waited for Professor Oswald's reply, and that reply never came. But in the meantime, his father also wrote a letter to Professor Oswald and tried to see how father is trying to plead with Professor Oswald to encourage his son. And he wrote, I beg you to excuse a father who dares to approach you, dear professor, in the interest of his son. My son, Albert Einstein, is 22-year-old. Everybody who is able to judge praises his talent. My son is profoundly unhappy about his present joblessness. I think this is worth underlining, that youth goes through these kinds of tribulations in life, and Einstein was no exception. And every day the idea becomes more firmly implanted in him that he is a failure in his career and will not be able to find the way back again. Because, dear professor, my son honors and reveres you, I permit myself to apply to you with the plea that you read his article and hopefully that you will write him a few lines of encouragement so that he may regain his joy in life and his work. My son has no idea of this extraordinary step of mine. If you read it again and again and again, you will find the kind of emotional touch which father lent to this letter and the kind of affection and love he has for his son and his work. Oswald actually never replied, and Einstein then proceeded further till this 105 year came, which is called a miracle year, in which, in fact, 4 papers were published. And one was on light quanta and photoelectric effect. Everybody knows about it. Then came special theory of relativity. Then came Brownian motion and the existence of molecules. And then mass and energy are interchangeable. That kind of thing happened. One very interesting feature of all this was that within no time after Planck published his paper, I think he was one of the first persons to realize the importance of looking at light as made up of quanta of energy. And he immediately used it to explain photoelectric effect. This was something very interesting in the sense that he was knowing that there is a phenomena which has no explanation. And once he looks at this concept of quantization of light, he can explain it very beautifully by means of a single line. That you have a light quanta falling on, say, a metal. Part of it is being used for bringing an electron just on the surface ready to come out, and the rest of the energy is imparted to the electron as kinetic energy. And this is where, he won a Nobel Prize also. And that was quite late, in 1921, he was given the Nobel Prize after almost 16 years. And the main mention which was made was of the photoelectric effect and his other theoretical works without much elaboration. Then comes special theory of relativity. And at the back of all this, there was something which was very interesting, which was already well known, but he gave a very different twist to that. Already Lorentz transformations were known to people. And in fact, in that Michelson-Morley experiment to explain null hypothesis, an ad hoc explanation was incorporated, which had some kind of seeds in the Lorentz transformations itself. What Einstein actually looked at was in a very different fashion. He looked at the electromagnetic Maxwell's equations, and he took those equations to see whether they are invariant under Lorentz transformations or not. So he was again, looking at something which is typically a hallmark of looking at the most fundamental aspect of a particular phenomena and checking it through this mirror of invariance itself. Now, the third paper, which was on Brownian motion and the existence of molecules, was very interesting because of the fact and for the interest that he had in thermodynamics. And here we find him talking about a many particle system, basically. And he was able to, conjecture the value of Avogadro's number, which was later tested and found correct. But I would like to tell you that between 901 and 905, he was given an invitation by this journal of NLDR Physics. I hope I'm pronouncing these correctly. That why doesn't he write some review articles on thermodynamics itself? So now you can see that here he was, going through one of the most fascinating areas of physics in the form of thermodynamics. And that is why, he had a very deep understanding of the behavior of these many particle systems. And that is how, he took upon himself to look at Brownian motion as a phenomena and establish whether the molecules exist or not. In fact, this also led to putting the atomic hypothesis on a very solid ground. The last paper, mass and energy are interchangeable, which actually led to this famous relation E is equal to mc square. If you really go through that, you will find that he, in fact, is searching for what is the origin of mass. And he didn't derive formula E is equal to mc square. Rather, he derived the formula m is equal to E upon c square. And these 4 papers would have been enough for a physicist or any scientist to, lead the rest of his life on these laurels of this kind of a seminal work. But he was not just happy with that. And he was, concentrating now, and he concentrated on that for quite some time, where he tried to give us the foundations of general theory of relativity. And he says that the happiest thought of his life was that gravity and acceleration are indistinguishable in a local frame of reference. And that is what made him develop the theory of general relativity. I'm not an expert in it, but I think these are very profound statements which really make you feel that how the mind of a scientist actually works. But the real check of his what you call theory came when he mentions that he has learned via telegram that 2 British expeditions who have gone to observe the solar eclipse have provided evidence of his prediction in the general theory of relativity that the gravitational field of the sun bends starlight. And I think one of those experiments was done in India also. I'm not very sure, but that is what I remember somewhere I read that. And that was the reason that general theory of relativity then had a proof. Now, I was talking about photoelectric effect. Very simple formula, back of a stamp formula it is. very easy to appreciate. And in fact, Millikan make use of this formula to do an experiment or design an experiment where he was able to calculate the value of the Planck's constant also. And you will find that in every college lab, you will find an equipment where students are supposed to find the value of the Planck's constant. And the physics behind that is what was given by Albert Einstein himself. Then in 1917, he wrote a paper that laid the foundation for stimulated emission of light, what we call as the laser. In fact, there is one thing which people talk about it is that when he talked about this idea, there was something which was missing, which he had not mentioned. And that took almost 60 years for other people to discover maser first and then the laser. And every school-going child knows that there are certain steps which one has to really follow or is in a system which has got a ground state, an intermediate state, and a third state. We try to go for population inversion, and then in a cavity, we try to stimulate the emission of light by letting those electrons fall into the ground state, stimulated by the other photons in the cavity itself. So this was in 1917. Maybe he would have got a Nobel Prize for this also. Maybe he deserved it that way. So as I was telling you, that he got a Nobel Prize in 1921 for his services to theoretical physics and his discovery of the law of photoelectric effect. And as they say, when Einstein first came to visit US, he was treated like a hero and a great scientist. I think this picture is telling us, these days, this kind of reception is reserved for either footballers or cricketers. But as a scientist, this was exceptional honor which was given to him, and exceptional what you call welcome which was given to a scientist. And most of the times people used to say that not very many people understand the theory of relativity, what he has actually done in that. Now, it was in 1925 that the story of Einstein and Satyendra Nath Bose actually begins. And that led to publishing of Bose's paper. And Bose had actually sent him the paper. He translated that paper into German, added a footnote to that, where he had mentioned that I will use this idea which has been explained here in explaining something related to the understanding of the specific heat of solids, where he talks about the model of a solid in the form of a collection of simple harmonic oscillators. And also later, he talked about the Bose-Einstein condensation. And Professor Modgill, in the last session of this seminar, gave a beautiful lecture on that. But we must really appreciate and understand one thing, that making a prediction and happening of that kind of an observation takes a lot of time. And this is not just true in one case as far as Einstein is concerned. There has been many, many instances in which Einstein made some kind of a prediction, and it took almost 70, 80 years for that prediction to be verified experimentally. Bose-Einstein condensation was one such case. And the reason behind this is that the kind of equipment which we require, the state-of-the-art equipment which we require, and Professor Modgill actually talked at length about how that cooling was actually achieved, which led to Bose-Einstein condensate. It requires the development of the technology also. And this has been true not only in the case of Bose-Einstein condensation. There are many other, examples which can be given. Electron is one typical example of that. That when electron was discovered by J.J. Thomson, before that, over a period of 60, 70 years, there were many things which were coming up, which came together to the discovery. For example, discovery of a vacuum pump so that we can create vacuum in that discharge tube. Then Giesler's tube, where you can seal electrodes in a glass tube and see what is happening when you try to apply electric field. The availability of very high potential difference of the order of, say, 15,000 volts with the help of a special, device, which you find will be there in the old, labs, which with the help of which you can, produce a spark between two electrodes in air itself. Those are the technologies, which slowly and steadily develop. And then we reach a point, suddenly they converge and find that a new phenomena has been seen. The same is the case with many of the things in which Bose-Einstein condensation actually happened. There is one example which I would like to tell you. And this is a quotation which is from George Gamow, a famous physicist who was very much into nuclear physics and astrophysics. He wrote somewhere that when I was discussing cosmological problems with Einstein, remarked that the introduction of the cosmological term was the biggest blunder he ever made in his life. And that term was actually added by Einstein to model the universe as a static model. Now, this is very interesting. And if you look at this, the day he conceived the cosmological term about 100 years back, it has been repudiated, refashioned, and resurrected. And there is a timeline over which you can see that how it happened. In 1917, he introduces that. And in 1917, March, after about 1 month, a Dutch cosmologist, De Sitter, produces an alternative model with a cosmological term. And this model is later shown to have accelerating expansion. In 1922, again, a Russian physicist, Friedman, constructs models of expanding and contracting universes without a cosmological term. Then in 1929, American astronomer Edwin Hubble discovers that the universe is expanding. In 1967, Russian physicist Borisovich estimates the energy density of the quantum vacuum and finds that it would make an immense cosmological term. So this is a very interesting part of it. And in 1998, two teams of supernova hunters led by Saul Perlmutter and Brian Schmidt report that the cosmic expansion is accelerating. A refashioned cosmological term would produce this effect. Since 1998, the evidence for cosmic acceleration has strengthened. So now you try to see how many twists and turns come when we try to look at the idea which Einstein proposed at one point of time, and then it is pursued by different scientists to see whether this is a reality or not, whether it explains something or not. So this is very, very interesting part of it. In the last lecture, which was given by Professor Sri Roop, he also talked about the GPS system. And I think, but for the relativistic correction, the GPS system would not have worked. Today, when I send a location to one of my friends where I am, you will always read along with that this location is correct within few meters. And engineers were actually, to begin with, very much puzzled that why they are not able to tell the right positioning of a particular location. And they found that they have to take care of certain terms which are there because of the relativistic corrections itself. So when you look at the clocks on board a satellite, which is orbiting the Earth, they run about 7 microseconds slower per day than ground clocks. And there is another element into it, which is the weaker gravitational pull on the satellite, which adds another relativistic effect, making clocks run 45 microseconds faster per day. Hence, a correction factor of about 38 microseconds is needed to yield accurate GPS data. So today, when we are saying that we are accurate within, say, a meter of the location which we send to one of our friends, it is thanks to this kind of a correction which we could identify must be made so that we are able to get the correct GPS system itself. Now, Einstein had a dream, in fact, that was his last dream. And later, after his, I think 1925-26, whole of his effort was devoted to space-time unification of fundamental forces. And before him, there were what you call examples of this kind of an unification happening. Newton unified terrestrial forces with celestial gravity. Universal law of this gravitation is an example of that. Maxwell and Faraday did unification of electricity and magnetism. Sir, please mute him, Mr. Anwane.
Sir, please unmute yourself.
Am I audible now?
Yes, sir. Yes, sir. You are audible.
Okay. So Newton unified terrestrial forces with celestial gravity. Then Maxwell and Faraday came and really gave that structure which unified electricity and magnetism. And in fact, before Faraday, Ørsted also played a very significant role in this particular direction. So it took almost, again, 40 years for, replicating Ørsted experiment, but in an opposite fashion. Faraday was asking this question, that if I have a magnetic field, can I produce a current in a conductor? So, whereas Ørsted was saying that I have a current carrying conductor and I am finding that there is a magnetic field because of it, and that's why the compass needle shows a deflection. Then came Heisenberg, Schrödinger, and Dirac, and they underlined the fact that the chemical forces are manifestation of electromagnetism and quantum theory. Einstein unified the concept of space and time and showed that Newtonian gravity is the manifestation of space-time curvature. Abdus Salam actually focused on the unification of electromagnetic and nuclear forces. So Einstein was actually looking at it right from the very beginning, that can you really think of unification of all the fundamental forces of nature? So I think this is high time that we start asking this question: what was the secret of Einstein's intellect? And there are very many, quotations which you can read attributed to Einstein. Imagination is more important than knowledge. Knowledge is limited. Imagination knows no bounds. Then somewhere he says, ask questions that nobody is asking. I stay on a problem longer than others. This is a very important trait of Einstein. And that is why when you look at his pictures also, when the pictures of Einstein are clicked, you will find him, in a kind of a trance, meditating about something. And he had legendary concentration whenever he used to think, whatever he used to think. That was something very great. In his autobiographical notes, Einstein actually tried to explain what is the meaning of thinking. And he says, when on the reception of sense impressions, memory picture emerges, this is not yet thinking. I think each and every line is worth looking at carefully. When on the reception of sense impressions, memory picture emerges, this is not yet thinking. And when such pictures form sequences, each member of which calls forth another, this is not yet thinking. When, however, a certain picture turns up in many such sequences, then precisely by such a turn, it becomes an organizing element for such sequences. In that, it connects sequences in themselves unrelated to each other. Such an element becomes a tool, a concept. I think that the transition from free association or dreaming to thinking is characterized by the more or less preeminent role played by the concept. Very often when we talk to our friends and we want to tell them that just try to understand it, we say, okay, look at the funda which is involved in it. So that funda is nothing but that kind of a concept on which we need to really focus. And this is a beautiful, way of telling us that how this is emerging. In many other contexts, you will find the same idea has been talked by even physicists like Feynman, where he used to say that the role of a scientist is nothing but identifying the patterns which are there in nature. And in fact, at one point of time, when he gave a lecture to the school teacher, he said, I was very much fascinated by the patterns which my mother used to weave on a sweater, on a cardigan. And there was a pattern which she will repeat and repeat for whole of the cardigan to take shape. So now try to see how two scientists are trying to describe the same thing in a very, very interesting fashion. As far as I remember, this was for the first time I found that somebody of the stature of Einstein tried to explain in his famous autobiographical notes what is the meaning of thinking. In fact, these are just 70-page notes where he has given his what you call scientific autobiography, which was it was published by Princeton University Press. And when he begins that, he says that at this ripe age, I'm being asked to write my own obituary. I'm feeling as if I'm being asked to write my own obituary. But I think it's a treat to go through those pages and see how, with very few equations, he tries to explain his journey of doing physics. So that is another aspect which I would like to mention. Then, there was another thing which is very much talked about Einstein, that he was very vocal about humanitarian things. And people used to describe him as man of conscience care, MC scare. So C stands for conscience. And he was definitely very much influenced by what Newton had done. That was like his role model. And in fact, he wrote an apology to Newton, where he said, Newton, forgive me. You found the only way which in our age was just about possible for a man of highest thought and creative power. The concepts which you created are even today still guiding our thinking in physics. Although we now know that they will have to be replaced by other farther removed from the sphere of immediate experience. That there was a time when somebody asked Einstein a question that how could you do so much? And his very interesting characteristic reply was this: I was able to do so much because I was standing on the shoulders of giants like Newton. And that is where, this apology also comes into picture. Newton, forgive me. You found the only way which in your age was just about possible for a man of highest thought and creative power. The concepts which you created are even today still guiding our thinking in physics. Although we now know that they will have to be replaced by other farther removed from the sphere of immediate experience. Again, he gave another tribute to Newton, and he wrote, nature to him was an open book. In one person, he combined the experimenter, the theorist, the mechanic, and not the least, the artist in exposition. I think the word artist is very interesting and typical mention here in this tribute of Einstein. Einstein himself also was, an accomplished uh, uh, player of what? I don't know whether you know that or not. Can anybody write in the chat box and tell me what was that which he used to play? Let me see if something comes in the chat box. I'm seeing chat box on my screen. And you know that instrument is the one which people say is able to reproduce human voice very nicely. Oh, yes. Kweta, well done. Sorry, Srivastava Pitale, well done. Violin. So he was the man who really was himself an artist. And I think only an artist can write that kind of a tribute. He stands before us strong, certain, and alone. I think I can replicate these words for even Einstein. This is a tribute to Einstein itself. For somebody asked him once that, what do you do? He said, I am a kind of a spy whose tools are pencil and paper and thought. And I try to see with these what is there in nature, what we can discover in nature with the help of these tools. So I think this is again a very, very, very interesting thought which is there. Now, Einstein also has a lot of connection with politics. I think we must really understand that. And in fact, he admits that also. He says, my life has been divided into politics and equations. Equations are more important to me because politics is for the present, but an equation is for eternity. So he realized the importance of both of these things. And I think everybody knows that he was one of the unwilling co-authors of history's most terrifying weapon through a letter which he wrote to President Roosevelt. He was also offered the presidentship of Israel, second president of Israel. He refused. And these are two very important, milestones of his life. And when atom bombs were thrown on Hiroshima and Nagasaki, someone asked him what was his state of mind. His reply was very interesting. He said, if I knew they were going to do this, I would have become a shoemaker. But this is part of the history. And this is the famous letter which Einstein wrote to President Roosevelt. And he talks about Fermi and Szilard. And in fact, this letter, they say, was drafted by Szilard and approved by Albert Einstein. And then it was sent to President Roosevelt. And that is how that Manhattan project of making of the atom bomb actually started. So this is, a letter which has shaped the destiny of our Earth in many ways. And later, he became a soldier of Pugwash movement, in which they were, trying to gather people together against atomic weapons, etc., etc. That's another story in itself. There is one thing which he mentions at one point where you can see his intermingling of scientific work and the kind of worldview which he had. My scientific work is motivated by an irresistible longing to understand the secrets of nature and by no other feeling. For first part, my love for justice and striving to contribute towards the improvement of human conditions are quite independent from scientific interests. So he used to see these two things as separate compartments. And he worked in both the compartments. He was for justice and striving to contribute towards. And I think he has really written a lot of articles on various mm, problems which have been there around us, uh, uh, even about the existence of the humanity itself. Now, I have really just made a book, a kind of a 2 slides on everyday Einstein. If you try to see, you will find that his ideas have worked at very many places. I think each one of them can be given to a student as a project to see where is the Einstein factor appearing in these. Photocopier to control the density of toner, electric eye, photocell, street lights at dusk and dawn, photomultipliers, TV cameras, astronomical detectors, solar cell, harnessing of nuclear energy, photovoltaic cells, DVD and CD players, laser printer, chemical reactions, manipulate microscopic objects. If you look at the list of Nobel Prizes being given in the last 125 years, you will see that at one point or the other, laser appeared time again, GPS sticks. And then he had one patent also, which was actually given to Einstein and Sizzler. That was on a refrigerator, which was not using that freon gas, but it was a kind of an oscillator, a refrigerator, which could work without that also. So naturally, when 2005 came, we celebrated that year as a World Year of Physics to commemorate 100 years of the miracle year 1905. And UNESCO, in fact, also joined hands to celebrate that year. And there was a lot of buzz in 2005 regarding Albert Einstein. To admit very frankly, this was the lecture which this presentation actually I made in 2005. I am giving this after almost 20 years. I searched in my hard disk where it is lying, and I found it. But after that, there has been another feather which has been added to the contributions of Albert Einstein. And that is the discovery of gravitational waves. And let me see if I can take you to the link where this has been described very nicely. And that is the beauty of, what you call internet, that you can take during the presentation also from one place to another place. And here is the timeline for the discovery of the gravitational waves. This is actually an article which has been published in Medium, an online science website, where a kind of a cartoon has been created that how Albert Einstein in 1916 started proposing gravitational waves as part of the general theory of relativity. And then Hermann Bondi, Felix Pirani, Richard Feynman in 1957 predicted that this is possible. Then in 1962, some Russian physicists published a paper in which they talked about gravitational interferometers. And I hope you must be remembering that the what you call labs which have been established for observing the gravitational waves are nothing but gravitational interferometer observatories, we are calling them. Then Rainer Weiss founded what we call as the LIGO project. Then in 1969, Joseph Weber claimed to have detected gravitational waves using a device called a resonant bar. Then in 1974, again, Rainer Weiss meets Skip Cohn, again another Nobel Prize winner, and convinces him that a laser-based instrument would give them the best chance of finding gravitational waves. And that is how these laser gravitational wave observatories were actually planned. And then very quickly, things started moving. And in 2015, we found that we were able to discover in those observatories the signatures of the gravitational waves. And we now know that India also has this project, which we call, I think, Indigo, worth around 1100 crores, where one of the interferometry gravitational laser observatories is being actually made. And one of the Indian scientists, Sanjeev Dhurandhar, who is at Ayuka, had played a very significant role in keeping the flame of discovery of gravitational waves, burning. He trained a lot of scientists in this area when everybody was, in fact, trying to say that this is an area in which one should not really work. But ultimately, this is what has happened. So this was one small, intervention which I made here. I must thank you for being there with me in this journey. And the references are here. Scientific American, September 2004, autobiographical notes by Albert Einstein. In fact, I have translated these autobiographical notes into Hindi. And I'm just looking for if I can publish it in India. I don't know to go to whom, because I wrote a request to the publishers, and they said, if find a publisher, let us know who can publish it, and then I will help you. But not very many publishers, were coming forward to publish that. Then Einstein's Last Dream is a beautiful essay which is available on the website of ICTP, Abdul Salam Center for Theoretical Physics at 3SC. And I think if you want to really understand Einstein further and you want to read it in a easy fashion, I think A Brief History of Time is the book which we must really go through. So thank you very much and hope you enjoyed it. I'm back with you. And I am there to listen to your comments and remarks and questions if there are any. I'll try to respond to you. Thank you very much.
Dear students, participants, and teachers, I would like to request you all, if you are having any queries, if you are having any questions, please.
Actually,
Anwane, sir, unmute yourself.
yeah.
Sir, answer to your question, violin was given by a student of BSc final year.
Oh, yes. Very good, sir. Congratulations.
Shrivas Pitare.
Okay.
I think there are students who can pose a question. Yugansh, if you are there, you can pose a question.
Students can also pose a question in the chat box if they desire.
Sir, you have very nicely covered the work of Einstein. And when I saw the list of 5 papers, I remembered the centenary celebration that was taking place in 2005. And you finally quoted that you have done this presentation earlier.
Yes. So I admitted it also, sir, that it was done in 2005. And in fact, Department of Science and Technology conducted some programs in different cities where they trained master trainers for this kind of a work. So I was part of that master trainers team for Himachal Pradesh.
Right. You have covered everything that has passed through the life and actions of Albert Einstein.
Only during 2005, we were not sure about gravitational waves.
Yes.
And there is one thing which I would like to mention, sir, that it is, something very, very strange and great also, that whatever Einstein actually has said and done, whenever it has been put to experimental test, we find that he is right always.
Yes, sir. Yes, sir.
Look at the kind of intuition this man must be having.
Yes, sir.
So that's the beauty of great minds.
Right, sir. When he was offered the post of President of Israel,
Yes,
he,
sir.
he very humbly refused and
Yes.
said that my equations are eternal.
Yes. I quoted one line from there also.
Yes.
Politics is for present, but equations are eternal.
Right.
Now, there is one question, Pitale. Sir, what is the physical significance of momentum? How can I really answer this question? Let me try to see if I can answer this. The physical significance, if I try to take it away from the mathematical definition of momentum, which is taught to us as product of, say, mass and velocity, I would say that it is the measure of the quantity of motion present in a body. And if you start from this definition and start doing a thought experiment, that what actually brings the quantity of motion of a body as a physical manifestation, you can do an experiment and ask, does it depend on mass? Does it depend upon velocity? And there is one very, interesting example which I would love to give you. That try to imagine that you are holding a bullet in your hand and you have a friend and you throw a bullet on her and she will catch that bullet. She will not run away. Now you bring out your gun, put that bullet in that gun and then try to, aim that gun at your friend. She will run away. Now what has happened? The mass has remained same, but the quantity of motion has increased because of the velocity which we have imparted to the bullet. The second part of it is very interesting, which is very much appropriate when we talk of it in Shimla, for example. Try to imagine that you are on a slope and you have a cricket ball and you let it go down. Okay. And you will find that you will not mind catching that ball with your own hand. Now imagine that there is a cricket roller which I am holding on the top of the hill, and I let this roller go down. You will find that now you will run away because the quantity of motion which is present there in it is because of the presence of the mass so high that you now know that it depends on the mass also. So very, very simply stated, momentums, quantification in terms of mass and velocity can be understood by these two thought experiments. I hope this has made some sense to you,
Yes,
Pitale.
sir. Thank you, sir.
Okay. There is one very interesting remark, and let me read that. Professor K.G. Bhole has said, imagine there would not have been an interaction between Einstein and Bose. It was Einstein who helped Bose to come to limelight. Is it true? Yes, sir, definitely. It is 100% true. There is no doubt about that. In fact, earlier, Bose had also sent that paper to Philosophical Magazine, and it was refused. It was rejected. And then he sent it to Albert Einstein. And Einstein immediately saw the importance of that. And I think in last two lectures, which you have attended, you must have seen that the significance of Bose's work lies that it came much before the real development of the quantum mechanics, which was happening at that particular point of time. And in the last lecture, Professor Siroop mentioned that when Dirac came to Calcutta and met Bose, he was, very much disappointed to know that he had not been made a fellow of Royal Society. And when he realized it, he went back and nominated Bose for being the fellow of the Royal Society itself. So there is no doubt about it, sir, that Einstein was responsible. Bose was a very interesting character if you had looked at him in the last two presentations also. I say interesting because of one reason. That he was, not a focused person the way Einstein was. He went to Paris. He was working in a lab where he focused his attention on crystallography. When he comes back to Dhaka, he tries to establish a lab, which again had nothing to do with what he had done in terms of that paper which was published earlier. So he strayed a lot here and there. And at one place, I think it is written about Satyendra Nath Bose that in early 50s, Einstein wrote a letter to him to focus on this unification ideas. And he started working on that. And he finished it. He was ready to write a paper to be sent to Einstein. And he received the news that Einstein is no more. So what he did was, with those set of papers, was he tore them off, threw them in the dustbin, and he wept like a child. So that's also a very interesting story, which is there. So I think there are lots of things, and that is why we are imagining that every month we should talk about a scientist, maybe from India itself, and correlate things around him and see how we can really inspire our students to take up science and physics as a subject.
Sir, Professor P.C. Deshmukh is also available online.
Yeah,
I would request Professor P.C. Deshmukh, sir, to sum up the lecture given by Professor P.K. Ahluwalia, sir.
No, I don't think I can sum up. It was such a brilliant talk, and covering Einstein's work is not easy. I just thought I will add one small comment. What you left out, Professor Ahluwalia ji, in your brilliant talk, was another piece of work for which Einstein could have got a Nobel Prize, which is his questions on quantum theory, on the
yes, sir.
Yes, because he asked if quantum theory was complete, and such penetrating questions that he raised, which led to a debate which took more than 3 decades to be resolved. Finally, based on John Bell's work and subsequent, it opens up the whole technology of teleportation and quantum computing. It very much comes from Einstein's work, but that is the class of scientists that Einstein was. That, his contributions to every area means you mentioned a number of reasons why he could have got a Nobel Prize, not just once. John Bardeen got 2, and Einstein could have got maybe 7 or 8 or 10. Great contribution, and I thoroughly enjoyed your covering it. And as you very correctly pointed out, what was not there in your 2005 talk was the discovery of gravitational waves, which you mentioned today, and that's a great addition. That insight that we get into physics from Einstein's work. Thank you very much. It was a wonderful talk.
Thank you, Professor Deshmukh. I'm really very happy that you pointed out. I was worried about time also,
Yes, of course. I know. There is only so much one can cover in a talk. And especially when you're talking about Einstein's work, it is impossible to find enough time to cover everything. It was a brilliant talk.
Thank you.
Thank you so much, sir, for having such a wonderful talk. We enjoyed it a lot. As we all know that Albert Einstein was a creator. scientist, inventor, and unmistakable are a few terms used to describe Albert Einstein. While many people relegate Einstein's powerful mathematician mind and to strictly scientific space, Einstein lived a life that has lessons applicable to a broad spectrum of areas. Today, you just took us to the life and work of Einstein. I just would like to just mention few things about with the audience that about IAPT, Indian Association of Physics Teachers, that is IAPT, is a grassroots organization which is working for the upgradation of physics teaching and physics teachers by conducting various academic programs and activities throughout the country. The vision of IAPT is to upgrade the level of teaching and teachers of physics and related areas of all levels to pool and mobilize the talents and resources of the teachers. In the national perspective, more than 10,000 members, 15 plus regional councils, and more than 150 plus IAPT regional councils are there. And Sir has been leading this association. It's truly a great thing for all of us to be part of this particular seminar. I'm very much happy and grateful that you took the time out of your busy schedule, sir, and threw a light on such a phenomenal happenings in the history and the life and work of such a great scientist. And you gave the terrific presentation. Thank you so much, sir. Moving on to the last part of this particular seminar, I would like to request Dr. Halim Ahmed, sir, for the vote of thanks. Please, sir.
Thank you, Jadhav sir. Am I audible?
Yes, sir. Yes, sir.
Yes, sir, you are audible.
So, very good evening to one and all. On behalf of entire Sub-Regional Council, SRC-08 of Indian Association of Physics Teachers, I would like to extend our deepest gratitude to Professor K Ahluwalia ji, President of IAPT, for delivering an incredible, insightful, and inspiring online lecture on respected master Albert Einstein, A Life from Physics, which has been conducted as an extension of the one-day national seminar on life and works of S.N. Bose, held on 27th January 2024. Sir, your eloquence and depth of knowledge captivated everyone, making the event a resounding success. Your ability to convey complex concepts in such an accessible manner truly reflects your passion for physics and dedication for fostering a love for the subject. Your lecture not only shed light on the profound contribution of Albert Einstein to the field of physics, but also served as a source of inspiration for all the participants. The way you seamlessly connected Einstein's theory to the real-world applications and modern-day implication was truly commendable. Moreover, your engaging presentation style and clarity with which you conveyed intricate concepts left a lasting impact on everyone in attendance. It was evidence that you not only possess a wealth of knowledge, but also possess the rare talent of making physics engaging and relatable to the diverse audience. We appreciate the time and efforts you dedicated to delivering such a enriching lecture to us. It was undoubtedly contributed to the intellectual growth of our members and reinforced the significance of physics education in our community. I also express my sincere thanks to Dr. Rekha Ghorpade ma'am, who is the motivational force behind the activities of SRC-08. Also, I express my sincere thanks to Professor P.C. Deshmukh sir, who last seminar coined the idea of suggesting the IUPAC for renaming the Planck's constant H as a Bose-Einstein Planck's constant. I also thank to many other people who are present. I cannot take the name. Once again, I thank you, your invaluable contribution to our sub-regional councils. We look forward for your future leadership and opportunities to benefit from your expertise. I also thank the President of Sub-Regional Council, 08 Dr. Anwane sir, and Dr. Gajanan Jadhav, who have compared today's program, and also his entire team of dedicated students, teacher who was working behind the curtain for the success of this event. I also express my gratitude to everyone who have participated, attended, and contributed to the success of this webinar. Thank you and have a wonderful evening.
Thank you.
So with this,
Sir, I before concluding, I want to mention that in the chat box, I have given link for feedback and link for quiz. The quiz is being developed. The quiz has been developed by Professor Reng Naiki and Professor Uttara Dorairajan from RC13, and we are very thankful for their help. I want to mention Professor Ahluwalia sir that I am very happy. We all members of RC-08E are very happy to get associated with the network of physics teachers. We are very delighted with the knowledge and command that all professors of IAPT are having. I want to say a couplet in Marathi for you all. वाचलेली ऐकलेली माणसे गेली कुठे, पुस्तकातून पाहिलेली माणसे गेली कुठे, रोज अत्याचार होतो आरशावरती आता, आरशाला भावलेली माणसे गेली कुठे. I found all these luminaries in IAPT and I am very delighted, sir. Thank you very much.
Thank you. Thank you. So thank you all, and see you again in some other program in the month of February. We will continue with this series.
Right.
So I'm signing off.
Yes, sir.
Okay, thank you.
Thank you. Thank you very
Thank
much.
you, sir. Thank you.